given the points A at -2, 3, 5 and B at 1, 0, -4. A, find the components of AB, so find AB as a vector. I'm going to do it as a column vector. B, find the components of BA. C, find 3AB as a vector. D, find OA plus OB as a vector. E, we need to calculate the modulus of AB, the modulus of BA. And F, calculate the modulus of 3AB and the modulus of OA plus OB. Right, so if we can find AB, then there should be a good start. So AB as a vector equals, so basically if you're going from A to B, you start with the end point or the terminal point, you could think of it as, so as in we're going from A, starting at A, and then you end at B. So if you use B's coordinates or take B as a position vector, which means how do I get from 0, 0, 0 to B? Well, that would be 1, 0, -4. So that's the position vector of B, which is literally as simple as the coordinates written as a vector, minus A, which is at -2, 3, 5. Okay, so this tells you how to get from A to B. You could put those in one bracket, but I think if you get lots of minus signs around, it's probably a bit easier like this. So 1 minus -2 is 3, 0 minus 3 is -3, and -4 minus 5 is -9, right? So that is AB. We could actually think about that as, we could pull a factor out of that, which may be useful. So you've got a 3 in all of these, so you could say, well, that's 3, and that would be 1 minus 1 minus 3. Okay, so that was part A. Now BA, yes, you could do the same, as in we could start with A's coordinates, -2, 3, 5, and then we could take away B's coordinates at 1, 0, -4. I say coordinates, I would actually do it with position vectors. But BA is just how do you get from B to A, it's the exact opposite. So I'm just going to say, well, BA equals minus AB. So it's -1, 3 minus 3 minus 9. So if we times all those by -1, you just need to change the sign. So that would be -3, 3, 9. That is BA, or, well, it's 3 times -1, 1, 3. Okay, part C. Find the components of vector 3AB. So 3AB, it's just as simple as taking AB and timesing it by 3. So I'm going to use this AB, but you could just as well use that. So it's 3 times 3 minus 3 minus 9. So that would equal 9 minus 9 minus 27. Or, as I was saying, we could have just used this. So if we multiply it to 3 by 3, or that would be 9 times 1 minus 1 minus 3. Okay, 3AB. Part D. Find the components of vector OA plus OB. So OA plus OB. Remember, if you see an O, it's a position vector. It means how do you get from the origin, which is for 3D coordinates, it's 0, 0, 0. How do you get from there to the point? So OA is going to be the coordinates of A written as a vector. So that would be -2, 3, 5. That is OA, and OB is exactly the same but for B. So 1, 0, -4. So you just add those up. -2 plus 1 is -1. 3 plus 0 is 3, and 5 plus -4 is 1. Part E, calculate the modulus of AB and the modulus of BA. Okay, so the modulus of AB, well, if we use AB is 3 minus 3 minus 9. So we're going to have to do 3 squared plus minus 3 squared plus minus 9 squared. In practice, you can just take the positives here. So for the modulus, it's just alongside Pythagoras. If you have the vector already, then you just square all the individual components, add them, and square root. It's just basically 3D Pythagoras, exactly what it is. I'm going to write this next line. So that is square root of 9 plus 81. Okay, so that then we can pull a 9 out of this, so equals the square root of 9, 1 plus 9. So that is the square root of 9 times the square root of 11, so the square root of, I'll write that down. Square root of 9, square root of 11 equals 3 root 11. The modulus of BA, remember modulus is just length, right? So BA just goes in the opposite direction to AB, so it's going to be exactly the same. Okay, so the modulus of BA is also going to equal 3 root 11. Okay, so we're now on to part F, and we need firstly the modulus of 3AB. So 3AB, the modulus of all of that. Well, if you think back to what you've done with modulus when we were looking at complex numbers, or just think what we did with absolute values, this can be written as 3 times the modulus of AB, because it's literally just the length. The modulus of AB means the length of AB. If we times it by 3, it's going to be exactly the same. It's just a property of absolute values. So the modulus of AB was 3 root 11, so it's 3 times 3 root 11, which equals 9 root 11. So, and if you want to go the longer way round, well, we already knew from part C that 3AB equals 9 minus 9 minus 27, like that. So that must mean that the magnitude of 3AB, the magnitude must be the square root of, well, it's going to be 9 squared plus, and you can put minus 9 squared, but I'm just going to put 9 squared. You're always squaring these things, so forget the negative. So 9 squared plus 9 squared plus 27 squared. Okay, so what can we do with that? So that is the square root of, well, 81 plus 81 plus 27 squared. 27 squared is quite complicated. Probably should have used a calculator. So 27 times 20 times 20 is 400. 20 times 7 must be 140. 20 times 7 is another 140. 7 times 7 is 49. If we add all of those up, you've got 400, 500, 600, 680, 729. And if you think about 729, does 81 go into 729? And if it does, then that could be a fact. If you think about 80, well, 9 8s are 72, so 9 times 80 is 720, and 9 times 1 is 9. So I can pull an 81 out of this, equals the square root of, it's going to be, if I pull an 81 out, 81 times 1 plus 1 plus, and we just said it was 9 81s. 1 plus 1 plus 9, so that is root 81 times root 11 equals 9, still equals 9 root 11. But you can see a clear argument for just remembering this here, because that was a lot quicker and a lot easier. The final part, it wants the modulus of OA plus OB. So from part D, OA plus OB, we work that out to be minus 131. So the modulus of that, is going to be the square root of 1 squared plus 3 squared plus 1 squared. Okay, 1 plus 9 plus 1 is just the square root of 11.